Okay guys, today we are going to be grinding valve seats. It's a pretty lengthy subject and I'm going to try to make a relatively short video given the content. Today we're going to focus on this exhaust valve seat right here. Reason to grind valve seats. If the surface is not in the correct degree, if it's not seating with the valve correctly, or if there's pitting, which we have here, you can see it in the image, or even for performance. So a little bit of knowledge on the valves. Most valves are at a 45-degree angle. So some of them are within a degree of that for a interference fit. It'll be 1 degree different than the seat, which is typically 45 degrees. That way it's called an interference fit, and it'll peen itself to be flush. The face will be flush with the seat over time. And that's something that some performance cars will have, and just many cars today. When the valve gets hot, it really no longer stays at a true 45 degrees. It does distort. So cutting them to say 44.5 or cutting the seat to 44 degrees will cause an interference fit and have it to have a dynamic fit once it actually heats up. So as far as the grinding of the seat goes, we're going to start with the 45-degree angle. This part I'm going to skip through relatively fast. But once you have your 45-degree angle grinding stone, you need to make sure that it is at a true 45 degrees. So we have this machine here. You can set it to 45 degrees, which you can see we've done. And then you simply run this grinding stone down and through. It's not set correct for this, but you can get the idea. So this swings at a 45-degree angle. This tip will cut the surface to make sure that it is at a true 45 degrees. Now when we grind the seat, we want to start with the 45, which will make the 30-degree angle, which is on top, and the 60-degree angle, which is often called the throat angle. It'll make that smaller as well. And then when you cut the 60 and the 30-degree angle, it'll make the 45 degrees smaller. When you cut the 30-degree angle on top, it'll bring the 45 smaller from the top. When you do the 60-degree angle on the bottom, it'll make the 45-degree more narrow from the bottom. There's typically a spec for the relief angle, which is also your 30-degree angle. This one right here on the tip. And there's also a spec for your 45-degree angle, a width. There's typically not an angle for the 60-degree, or sorry, a width for the 60-degree angle, and that's because once you get the 30-degree angle width correct and the 45-degree width correct, the 60 kind of takes care of itself. Once again, you can use the 60 to bring up the 45-degree angle to make it more narrow. To start, you want to get a shaft that'll fit into the valve stem guide. As you can see, we have an assortment here. We've gone through and I've picked the one. Fortunately for us, the intake and the exhaust are the same size. And you can't tell, but this is slightly tapered. So just go ahead and put it inside of the guide. And once you got it in there, wiggle it just a little bit so it sits in there. And you want to push down until it sits nice and flush. And there's no free play. Any free play will cause this to be inaccurate. From there, we want to pick a spring, and this just alleviates our grinding stone from always being in contact with the surface. I'll try to get a good video of this. As you can see, there's a little bit of give. Well, that give is keeping this grinding stone up and off the surface of that seat. So what we're going to do first is grind the 45-degree angle, which is the most important because that's the actual seating surface. And once we get that smoothed, we'll check the width on that And we'll go to our 30 degree and then finish up with our 60 degree. And I'll kind of go through the steps and show you how that's done. All right, so we got the grinding stone set up with the spring under. I'll go ahead and give you guys a forewarning. There will be some sparks from this grinding stone hitting on the top of that spring. Not a major issue at all. We want to make sure we have our coolant set up, and we don't want to hit the grinding stone because it'll flash everywhere. What we really want to do is have it spray against the seat and kind of swirl around the seat. I'll show you guys what I mean. So if you can see that, you see how it's swirling around the seat? That's what we want. We just want to keep it cooled and lubricated. I'll go ahead and turn this off for a second. And with that being cooled and lubricated, we'll go ahead and grind that surface just to the point where it's cleaned up. We really don't want to take much more off than we need. One crucial step that I forgot that can really help us make sure that we are taking off the right amount of material. For us, our width on our 45 degree angle is 55 thousandths to 71 thousandths. So with our digital caliper, we have an idea of what that looks like. We can really help ourselves if we clean the surface and take a pen. Let's get this spring out of the way. She'll get everything out of the way. How about that? Okay, we got the spring out of the way. I get my pen to work. So this is a Sharpie. That'll work just fine, but we're gonna mark. And I do 4 spots. Some people do 3 spots. I like 4 just because it's a little bit more spread out and I can really see what's going on throughout all of the valve seat. We'll mark it here and we'll mark it up here. Okay. And if you guys can see that. So then when we go through with the 45 degree grinder, we'll see exactly how much material we've taken off and the new width of our surface. Okay, we're all set up, ready to go. We have our coolant and our lubricant going. We're gonna put this inside of there. When we do this, we're gonna do a few bursts. We might only really need 1 or 2 to get that face to really smooth out the way that we want. Let me see if I can get a good view of that here without making too much of a mess. See how we have some give in there, so we'll go ahead and just run it and then grind our surface. Alright, let's take a look. Let's see how we did. Let me go ahead and get this out of our way. Alright, so now if we look, you see where the black marker is gone is the surface that we went and removed. So now we need to measure that and see how wide we are. Just by looking at it, I'm guessing we're a little bit wider than the 71 thousandths of width that we're supposed to have for that 75 degree angle. Okay, so as you can see here, I got a caliper set to 71 thousandths, which is the maximum width of our 45 degree angle. Let's see how we did. So you just want to lay it on top. We are pretty much right on 71 degrees. So what does that mean? That means our 45 degree width is its maximum width, which is a good thing. So then what we can do is we can bring We can now grind our 30-degree angle, which is going to be the majority of that black material in there, and here, and here, and here. And what that angle is for is to help airflow. And one thing that I'll mention is if you grind that 30-degree and it's 30 degrees too large, there is a spec on that. What you can do is put a 15-degree on the outside of that, and that actually helps improve airflow even more, as well as keeping that 30-degree in spec. Once again, the 45 is the most important. That's where the valve seats against the head, and that is actually what cools the head, is that transfer of heat through the seat, through the mating between the valve and the seat. So what we'll go ahead and do now is grind our 30-degree. The spec on that is 19 thousandths to, I think, 25 thousandths. I'll double check. But we want to grind that until it's in spec and keep the 45-degree in spec. And then do our 60-degree and still keep the 45-degree in spec. But this is the best way to do it, and hopefully this process is showing you that. Okay, I went back and I added in the black Sharpie. That way we can once again see the material we're cutting. And if you could see this lip, that straight edge right there, that skinnier one, not the one we just did, but the one just above it, that's the 30-degree angle that we are going to grind to smooth out. And this isn't as important as our 45-degree as far as it being smooth, but it being smooth does help get the airflow in a little faster. And once again, we'll show you how to set this up. So we're going to put our shaft inside of our guide. And push it down there. It's taper fit, so a little tap on top will make sure that it's nice and flush in there so that we have no play. What you're seeing is the entire head move, but this shaft is actually nice and solid inside of our head. Alright, so we got the grinding wheel set up. One thing that's important to note is that the size of the grinding wheel does matter. If it was too large, we could cut some of the material from the actual squish area, the combustion chamber, which we don't want to do. It kind of messes up our swirl that's designed into it, the turbulence. So we just want to go ahead and drop it in, make sure that we're good there. Alright, we have a coolant set up. We have the black around the edges marked, so we can actually see how much material we're removing with the 30 degrees, and we'll go ahead and go for it. Okay, let's take a look, see how we did. You can see with the black that's removed, the material that we just took off, and we'll go ahead and measure that and make sure that we're within specifications. Okay, so one helpful trick I'll show you guys. If you noticed, after we cut that last 30 degrees, we could see where it cut, but it didn't clearly define the 30-degree angle. So I'm going to show you how we can see that. Once again with our marker, and this is a Sharpie. You can really use any type of felt tip, marker, pen, or whatever you want to call it. You just wipe the coolant, the lubricant off of the surface. We'll put another black mark on it. And then if we put our shaft back into the slot, like so, what we can then do is take our 30 degrees that we just cut with, no spring installed. We can put it down on top, and if we rotate it just a few times, not much. Let's see, maybe a little bit more. We can actually see where, see the black on top, so that's what didn't get cut, but the bottom black ridge is what did. And if you look right here, this is what we want to see. So you see how there's still a lot of black right there? So that's not grinding. So that is what we'll call a low spot that we need to go over to make sure that this surface is uniform. So we'll go over that and get that black spot removed so that it actually is an even 30-degree surface all the way around. For the sake of time, I didn't include the grinding in that time, but I also didn't remove the Sharpie, and if you could see now, that Sharpie was removed and is removed from all the other surfaces, so we know that that area that was a low spot is now uniform with the rest of the 30-degree surface. So now we need to figure out what that means for our 45-degree surface. So like I said, when you do a 30-degree surface, it makes the 45 degrees surface more narrow from the top. So what we'll do once again is go ahead and put Sharpie up and around that seat. We'll put the 45-degree grinding wheel onto the shaft and just rotate it around with our hands a couple times to see and make sure that the 45-degree surface is still thick enough. Okay, so I went ahead, got the black marker around, and we're going to check for the thickness of our 45-degree surface. Also, if you can see, you can tell we're doing a good job because you can see the 3 defined angles in there. But we're going to go ahead and grab this and make it really defined. So we'll take this and get a good view. Okay, it's decent. Scratch it around a few times, lift up. Lo and behold, our 45-degree surface is now clear and able to be made out. So what we'll do now is go ahead and measure the thickness on that and make sure that we're still within spec. Okay, let's get a video of this. So if you could tell, try to get it set up to where you guys can see it. Our 45-degree angle is now under our maximum spec, which is what we want as long as it's not below the minimum spec, because we still need to clean up that 60-degree angle. If you can see that 60-degree angle, it's still really black from all the carbon buildup that's on it. We can't even see the Sharpie. So what we'll do now is figure out if we are still above our minimum spec, and if so, then we'll go ahead and cut out our 60-degree angle. And let's check the minimum spec. Alright, so we are at our minimum spec of 55 thousandths. We'll come in here and check and see how we are doing. And if you can see that, we are slightly larger, not by much, but slightly larger than our 55 thousandths minimum thickness, which is what we want, but we have to be careful with how much material we take off of the 60-degree, because we can very easily take that, make it too narrow so that it no longer is wider than 55 thousandths of an inch, and that means that we'd have to go back and just kiss our 45-degree to bring it back within specifications. So let's go ahead and do the 60 and see how we do. Once again, paint the surfaces so that we can see exactly how much material we're taking off of them. Just makes it a lot more vivid. Alright, Sharpie at our 4 sides. Let's go ahead and clean up that 60-degree seat. We got our 60-degree grinding, and once again, I already went through and trued it. So it is a true 60 degrees all the way around. So we'll put our spring on, stick it down inside. Okay. We've got good movement. Let's go ahead and get to grinding. And mind you, we don't want to take off much, just a little bit. Okay. And now you can see the 60-degree surface is nice and clean. And we still have our 45 and our 30, and you can see the other one at top. That one up top is that 15-degree relief on top of the 30 degrees, which is what I was talking about earlier, and that just helps with airflow. But you can tell we're doing a good job because you can see the clearly defined angles, nice and clean and ground within the valve seat there. Okay, once again, we want to see our 45-degree angle, so we'll clear off the coolant in the water, add in more Sharpie over the existing, take our 45-degree grinding stone with the shaft installed so it's concentric, and then we'll see and make sure that our 45-degree angle is still within the right thickness. Okay, we just cut our 60-degree, we got the sharpied surfaces. We'll grab our 45-degree grinding stone, place it on top of our centering shaft, and work it around a couple times. Mind you, we're not pushing hard or just rotating it on the surface. We shouldn't need to push hard because the surface is uniform. Okay, so we're actually looking pretty good. Thickness looks good. I'll measure it here in just a second. And one thing that concerns me a little bit, if you look there, all of our 45-degree surface does not look like the grinding stone, just moving it by hand, removed it. So we'll go ahead and place on top again. And what we'll do is we'll rotate the grinding stone 180 degrees, and then we'll spin it at that 180 degrees just to see if we have a low spot in our grinding stone, which is very possible. Sure enough, we pull it up, and let's get a look at it here. There we go. Then you can see that all the surface is removed. We just had a little bit of a low spot in our grinding stone, which isn't bad. We know it's concentric. The rest of it's trued, so we're doing okay. So now we'll go in and measure that thickness to make sure that we are larger than 55 thousandths and smaller than 71 thousandths. All right, we have our digital caliper. It's set to 55 thousandths. We were concerned about it being too small, so we'll go ahead and check the minimum specifications to make sure that we are doing okay. And if you could see, we are pretty much right dead on. Couldn't get much better than that. So this angle will also widen ever so slightly as the valve beats up against the surface of the seat. So being at the minimum is not a bad thing. Being smaller than the minimum, however, is a very bad thing because we need a nice wide surface for the seat to transfer heat into the head and to cool the valve, that way we don't get a burned valve. So what we can do, and we don't have to, but we can on this particular seat, is we can go back over it now with the 45, just enough to widen that. In fact, I'll go ahead and do it just to show you guys the difference it'll make. To bring it, we'll shoot for about 60 thousandths, just maybe even 65. In between that, it's 55 thousandths and 71 thousandths range. We'll go ahead and do that now. Okay, we have our coolant lubricant on, painted surface. We'll grab our 45-degree grinding wheel one last time. Go ahead and put it on top. And we're going to make that surface a little bit wider, which makes the other two more narrow, which is okay. The 45 degree is the one that's most important, and the other two are well within specs. We'll go ahead and widen our 45 and take our measurement. Alright, pull this out, turn off your coolant so you can see our surface, and I can visibly tell that it's now wider. Hopefully not too wide. If so, we can fix it, not too big of a deal. We'll come in here and we'll check our minimum. Get it to where you guys can see. So if you can see, we're now wider than our minimum, which is what we want. We'll check our maximum. Sorry for the darkness while I'm getting this set up. Okay, so we're at our maximum, 71 thousandths, showing 71 and a half. It's okay. So we'll check it here, and we are within our maximum. Let's see if you guys can see that here. So there's our maximum, and we're just inside of it, which is exactly what we want. So we're probably right around the 67 thousandths range of width, which is exactly where we want to be. So this valve is now ground. All of the angles are where we want them. Our 30 degree, we can check that again. I can visibly see it's probably about where it needs to be, but it's always good to measure. I'll go ahead and measure that just to make sure we're still within specifications. And that's, if you check the specs, it's often called the relief angle, which is also that 30 degree angle. And after that, we need to do some last checking to make sure that the valve is going to seat correctly. I'll go ahead and get that going. Okay, so now we need to check that this valve is mating up in the proper spot with the seat, and that all areas of this valve, which is freshly ground, we ground this to 45 degrees, is uniform with this seat, which is also at 45 degrees. So what we'll do is paint 4 different areas on the valve and 4 different areas on the seat, and we'll drop the valve into the guide. I'm trying to do this with only one hand. I'm not sure how I can. Let's see if I can prop this up here. That's where you guys can see. So we'll push up at the base of the valve just to relieve some of the pressure off of it so that we can rotate it. And we'll rotate the valve. Hopefully you guys can see that. I'm just pushing up on the tip of the stem just enough to allow the valve to rotate and still have pressure on it all the way around. So as I'm doing this, what this is doing, any low spots in the valve will show a thick black line without any cleared mating surface, which shows us where the low spots are in the valve. And any black that's not removed from the seat is a low spot in the seat on the 45 degree surfaces. So of course it doesn't show the 30 and the 60, but we already checked those surfaces with the grinding stone on the seats. So we got this turned around a few good times. Good pressure, we'll pull it up and take a look at it. Okay, so on our seat, on the valve, we want to be seating, it's a little shiny there. Let's see if we can get a better angle. There we go. We want to be seating pretty much dead center on that valve, which if you look, we are just about dead center, which is what we want. There we go. So we're a little bit high, but not bad. It will do, and as this valve wears in, it'll actually move further and further towards the outside as it kind of mushrooms itself inside of the head. So we're doing pretty good there. And notice that each section has material removed, which means that we do not have a low spot, and this valve is true at 45 degrees. And we'll look at our head at the seat, and if you look, we are on our 45 degree surface. Every spot of it is has a black removed. There's a little scuff down there. That doesn't concern me. For the most part, all of it is removed, and this valve will work itself into the seat a little bit just by running it with the engine running. So at around 3,000 RPM, this valve will be bouncing off of that seat about 50 times per second. So that'll tell you how many times this thing is getting hammered in into the head. So that is how you grind the seats and check that the valve mates up correctly. We'll do a further leak down later on with the valve and some different methods to check that it actually is holding air in and out of the combustion chamber, which is what the valve and the seat is designed to do. Thanks for watching. Hopefully this was very quick. Hopefully it answered a lot of the questions and showed you guys the process and how it's done, and a few other things. So one thing I want to mention, notice how this is a little bit high. We could bring that lower. Mind you, it sits in the seat like so. So if we want to bring that high area, which is at the bottom of the valve, up, what we'll do is we can do one of two things. We can grind our 60 degree, well really one thing, we can grind our 60 degree angle deeper, which will narrow that width and bring it up higher so that it's further towards the middle of that valve. But we are within specifications, so we're not going to worry about that. But if you needed to, that's how you do that. All right, once again, thanks for watching. Take care, and we'll see you again soon.